Hey everyone. So I'm going to try to keep this video as succinct as possible, which means as we go along, please, 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 you need to pause as you personally need to. And if you have any questions, you need to contact me via email or via Teams chat, whatever. All right, so let's access our 7.5 homework, and I'm going to go through and give you guys a snapshot of each problem. Okay, so let's get to it. All right, so we combined lesson 6 and 7 because they got a lot of the same ideas. So we just want to kind of group them together so we kind of keep rolling with things. So our goal is going to try to write expressions in factored form. And the reason we do that is so we can invoke zero product property, ZPP. If we can get two quantities related together by multiplication and they equal 0, we know a lot about the solutions. We can just set each piece equal to 0 and we can solve for our x's. So if we get things in factored form, we can utilize zero product property. So this is a good warm up. I want you guys to pause. I want you to pause and try to figure this one out because it's a good thinking problem. Okay, so hopefully if you're back from your pause, right, I'm going to just walk you through how I thought of it. It's not the only way to think of it, but it's just how I see it. So if I'm looking at figure A and I'm trying to find the square footage of this rectangle here, I know that I need the length and I need the width. So the first thing I kind of see is I see two dimensions here. From the top all the way down is 10, and from the top down to this section is 8, which means there's going to be a piece of 2 left over. So I know that one of my dimensions is 2. And looking at my width, I know that from here to here would line up and be 8. From here to here is 5, but I know part of this here is 3, which must mean there's 2 in this gap left over, which means this ultimately is a dimension of 10. So I know I have a 10 by 2. So it's a 20 square inch piece. Then in figure B is a little trickier. We're trying to find this missing dimension here. So I'm trying to look for something where I know at least like 2 of the dimensions, right? So if I have area equals length times width, I'm just trying to find somewhere where I have 2 of those. And I'm going to hone in on this here because I know that the area is 60 and the length is 12, which makes this must be 5, which then means that kind of looking from over here would also be 5, which makes this whole length 8 on this side. And since it has a square footage of 48, it means this side is 6, which the side up top here is 6. If the whole thing is 11, it means this must be 5. Which again, if the whole thing from here, because I'm pulling this from down here, is 12, that means a piece of 3 and a piece of 5 is 8, which makes this 4. And we know the factor pair 9 times 4 is going to give us 36. So that's 9 inches. That one was a little more complicated. But I hope you guys kind of challenge yourselves and maybe some of you got it. All right, let's get rolling. So we're trying to bring back this idea of the diagram. Even if you are a foil pro, and I appreciate if you guys are good at foiling, I want us to think back to the diagrams because it's just going to help us visualize it and lay things out. So if you remember, what expression does this diagram represent over here? Well, what it's saying is that we had a piece of an x and a 2 piece, and we were timesing it by an x and a 3 piece, as you can see along the dimensions on the top and on the side. And what it also shows is that when you go and do the multiplying, that we also have the expression, we add up all the areas, and it's also representative of x squared plus 5x plus 6, because that's all of the total area that's in each of the boxes. All right, so then we threw in some negative numbers. We said, what does this diagram represent? So we kind of lose the idea of area in real life, but we can still use negative numbers, right? You can't have negative dimensions, but it's just a diagram. So this represents x and a -6 piece, and this represents x and a -2 piece. And again, we're multiplying those things. So then we say, okay, well, what expression or number goes in each blank? Well, we find our little areas. X times x is x squared, x times -6, x times -2, and then -6 times -2 being positive 12. So really what's represented here is x squared minus 8x plus 12. All right, so again, right, we do that via foiling, but we're trying to bring it back visually. So now here's 6 examples here. And we want to try to find a pattern. When we multiply, and I want you guys to keep this in mind, is that the generic or the general equation for a quadratic is ax squared plus bx plus c. And I want you guys to focus in on the b term and the c term and where those things are coming from. So, for example, I think some of the best ones are to start are down here. So look what happens. You guys know that if you want to get the c value from 2 binomials, you multiply the last 2 terms. That's something that we know. Like, boom, you want to find the you want to find the y-intercept, multiply your 2 constants, multiply your 2 constants. So the constant times the constant gives us the c term. So hopefully we are on board with that, right? Same thing. 4 times 10 gives us the 40. -5 times -1, right, gives us the positive 5. -1 times -7, right, you got to take the sign in front, gives us the positive 7. Okay, so we know that the constant times the constant in your binomials is going to equal your c term. But the question is, where does the b term come from? Well, hopefully what we're noticing, right, is that 2 times x gives us 2x, 4 times x gives us 4x. In total, we have 6x. 4x, 10x, 14. -5, -1, -6, and -7, -1, -8. So we should be able to, hopefully, we can say, okay, well, wait a minute. The 2 constants in the binomials, instead of timesing the 2, and I know that looks like a t, but it's a plus sign, the constant plus the constant gives us our b term. Let's even go up here and make sure that this works as well. 3x times, well, this would really be kind of like a 0. So this would really be a 0x. Hey, it still checks out. You still get 3x. -6x, again, if this were a 0, this would be 0x. So we still get -6. So it still works out. So the pattern that we're hoping to pick up on is that exactly what we just said here, is that in your binomials, the constant times the constant gives you your c term, and the constant plus the constant gives us your b term. So relating them by multiplication gives you your c term, right? Multiply the 2 constants, you always get your y-intercept. Multiply the last 2, multiply the last 2. 2 times 4 is 8, 4 times 10 is 40. Negative times negative gives you positive 5. Negative times negative gives you positive 7. And then your b term is a result of those same constant values. It's just they're getting added up because you're adding up the total area in these boxes. -5 and -1 makes -6. -1 and -7 makes -8. Okay, so that's what we're going to build on here. So let's rewrite some expressions. First, we're going from factored form into standard form, or we might have to go back. So we know that factored form into standard form, right? We don't need to, we can just distribute. So we know x times x is x squared, x times 7 is 7x. And we know if we wanted to go backwards, well, we would kind of divide out this x and slide it in front. So we'd have x times x plus 9. Or same thing down here, x times x minus 8. And we could always go back and check it, right? X makes x squared, 9x, checks out. X times x squared, x times negative 8, negative 8x. And then again, right, even if you guys are comfortable foiling, right, I can do this all at once. You guys will start to get better. But remember what we said, guys. Remember the pattern. X times x is going to give us x squared. Then you look at your two constants, 2 and 6. The sum of those gives you the b term. So that should be an 8x. And the product, or if you multiply, should give you your c term. Now let's just make sure real quick. I'll just prove it to you guys if you don't already believe it from foiling, right? X squared plus 2x plus 6x plus 12. Sure enough, these combine to be 8x. So we're good. Now when we have to go back from standard form, remember what we're looking for. Two binomials with an x and an x. And the two constants are going to multiply to 12, but at the same time, they're going to add to 13 because that's our pattern. Constant times constant gives you C. Constant plus constant gives you B. So if I think of the numbers that multiply to 12, right, we got to start thinking of factors. Well, right, 1 and 12, 2 and 6, 3 and 4. What are the only ones that can combine to give you 13? Well, it's got to be 12 and 1. So a 12 and a 1, and they need to add to combine to positive 13. We're doing it. Here we go. Okay, we're good at going from factor to standard. So that's x squared minus 8x plus 12 because, right, we got positive, two negatives make a positive. All right, I am getting what seems like an urgent text. So hold on, I'm just going to pause this real quick. Hold on. Okay, turns out it was not that important, but whatever. Okay, so anyways, yeah, we're cooking here. We're cooking with gas. All right, so once again, we're just trying to put this in factored form. We're trying to think, what do our binomials need to be when we know that the two constants need to multiply to our c term, right? They need to multiply to our c term and then combine. I don't even want to put symbols in there. I'm just confusing people. No, it's good. Let's go. All right, let's think of the factors of 12 that are going to combine to make negative 7. Well, that means that both of our numbers have to be a negative because in order to multiply to be positive 12, but add up to a negative number, they both have to be negative. And what are the only factors of 12 that have a chance to become 7? Well, it's not 2 and 6. It's not 1 and 12. So it's got to be 3 and 4. Let's go. We're rolling. Let's cook. Let Russ cook. Let everybody cook. All right, so once again, what multiplies to 9 adds to 6? Well, think of the factors of 9. Got to be 3 and 3. Positive 3, positive 3. 3 times 3 gives us 9. 3 plus 3 gives us 6. Let's do another one with 9. Now we have multiply to 9, but they're going to add to 10. So it's got to be 9 and 1. Get out of here, email. Now we keep going with 9. Now they're adding to negative 10. Well, guess what? We got to flip them to negative. Negative 1 and a negative 9. Remember, guys, the constants have to multiply to 9, not multiply to 10. They got to multiply to the c term. Negative 1 times negative 9 is 9. Then you add them up, and it's negative 1 plus negative 9, which is negative 10. And then, of course, we got the last one. Look what they did. They just flipped the b term on us. So what? Negative 3 and a negative 3. This is stupid. Don't worry about that one. Okay. So we're thinking factors, factors, factors. Okay, right? Good. What are the multiplies to c, adds to b? Our constants. We know from the very beginning, we know that constants multiply to give us our y-intercept, which is our c term, right? Constant times the constant gives us the y-intercept c term. constant plus the constant gives us that middle term. That's what we took from here. That was our pattern. So now what happens when you have it? The thing about this, guys, look at all your constants. 12, 12, 12, 12, 9, 9, 9, positive, 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 positive. Okay, what happens when you have a negative constant term? So real quick, recall, if two values multiply together and the result is negative, if a number times a number equals a negative, then what must be true? Well, wait a minute. Positive times a positive is a positive. Negative times a negative is a negative. Oh, that's right. So we must have one negative and one positive. The pattern still holds, guys. The pattern still holds. Okay? So these are the ones that we just saw before. Both binomials have a positive constant or both have a negative term. What do we know will be true about the standard form? Right? A positive constant term or a negative constant term, we know that the C value will be positive, right? Because it's either positive times positive gives us positive or negative times negative gives us positive. But then look at what we're switching up to, right? Now we know that if our constant is negative, right? If our C value is negative, we're going to have one positive times one negative. So we just still got to think. The pattern still holds, guys. The pattern still holds. Constant times constant gives us C. Constant plus constant gives us B. All right, here we go. We can start with this one. We're good at this. So we're going to have x squared. We're going to have positive 12x minus 3x, which should give us 9. And then 12 times negative 3 is negative 36. Okay. Now, we need to find the factored form. So let's ask ourselves. We need two constants that multiply to negative 36. That means, guys, we got to have one positive and one negative. We know that because if two numbers multiply to a negative, one's got to be positive, one's got to be negative. So now let's think of factors of 36 that if one of them's positive or one of them's negative, just think of factors of 36 that have a chance to somehow combine to be 9. So essentially, they're 9 away from each other. Well, it's not going to be 1 and 36. Those are too far apart. It's not going to be 2 and 18. Those are too far apart. But if we go to 12 and 3, right? If you took 3 away from 12 or 12 away from 3, you would get some value with a 9. So the question is, which one becomes positive? So we know we're going to use 12 and 3. Which one gets the positive? Which one gets the negative? Well, since they combine to be negative 9, that means we need the big 12 to take the negative, and a 3 gets the positive. Because if we were to go back and FOIL it, we would get 3x combined with negative 12x, which would give us negative 9. Okay, same thing. Multiplying to negative 36. That means one positive, one negative. Now they're going to combine to give you 35. So guys, it's got to be 36 and 1. And the question once again, which is which? Well, since it's a negative b term, and they're going to add to a negative, that means the big number needs the negative, 36 and a 1. And look at the only difference in the last one. All they did was switch it to a positive 35. So we're going to do the same thing. We're going to go plus 36 and minus 1. Look at us go. Name some of the ways. Psh, get out of here. We're doing it. All right. Now, here's a couple, right? Here's a couple different things here. They're all similar expressions, but it's just a question of how is the 100? Is the 100 positive or is it negative? And then how is that going to influence our factored form? All right, here we go. We notice a positive C term. That means we either have a positive times a positive or a negative times a negative, right? Because our constant times our constant gives us our C term. Since our B term is negative, that means we got to go with the negative times the negative. Running low on battery. Battery juice up. Okay, so that's the thing, guys. If we structure this, now we can just fill in, right? Now we can just look for the numbers. We know then it's got to be two negatives because they add up to be 25. And we know that there's two negatives because they also multiply to be a positive. Let's think factors of 100 that could combine to be 25 somehow. 50 and 2, no. 25 and 4, close, but no. 20 and 5. Look at us go. 25. Negative, negative will add to negative 25. Negative, negative will multiply to positive 100. Okay, we got a negative C term, which means we know we have a positive times a negative. Done deal. So we have an x plus and an x minus. Get those constant terms that will add to 15, but one of them is positive and one of them is negative. So they're basically 5 apart. Hey, guess what? It's 20 and 5, right? Give the 20 the positive because it's positive 15. Give the 5 the negative, still multiplies to 100. Same deal. X plus, x minus, I know that because it's a negative C term. And look, all they did was change the 15x on us. Now they just made it negative. So instead of the 20 getting the plus, the 20 is just going to get the minus. And then lastly, it's a negative C term, so I'm going to have an x plus and an x minus. 99, so I know I'm going to have to use the factors 100 and 1. So 100 gets the positive, 1 gets the negative. We're doing it. We're doing it. How would you explain how to rewrite this in factored form? Of course, you can explain it however you want, but maybe let's kind of make it explicit what we've been saying this whole time. Okay, so we look at the C term to see if it is pos or neg, right? That will tell us the signs inside the binomial, which in this case we have 1 plus and 1 minus because the C term is negative-ish. Okay, good. And then we look for, or we think of factors of 24 that could combine to be 5, or they are 5 away from each other. Something like that, right? And we're thinking, 8 and 3, 8 and 3, So we know it's going to be 8 and 3, and then we look at the B term to see it is negative, so the 8 must get the negative. And lo and behold, x minus 8, x plus 3. Bada bing, bada boom. Look at us go. Okay, the cool down is pretty straightforward. We're filling in some missing numbers and then some missing symbols. So why don't you guys should pause. Okay, now that you're back from the pause, great. Okay, all we're doing is looking from standard form to factored form, standard form to factored form. We got to make sure that these things match up. So we're given factored form. We know that, look at your two constants. They're going to multiply to give you the C term. They're going to add to give you the B term. 18x and 17. Same thing. Your two constants are going to multiply to give you your C term. Well, 2 times what? Got to be 7. 7 plus 2, sure enough, gives us 9. Checks out. Same thing, right? 2, this has got to be a 5 because negative 2 times negative 5 would give us 10. Also add to negative 7. And then, all right, we're looking for factors of 20. Both negative that are going to combine to be 9. So we know it's going to be a 5 and a 4. Now, we might also want to throw in some missing symbols here, possibly, second part of our cool down. So if we know that here's our factored form, a positive 1 and a negative 17, that means positive times a negative has got to be a negative. And then which, right, you're going to have negative 17x's and positive 1x's. Well, those are definitely going to combine to be a negative 16x. Okay, all they did was flip. Look what they did. They flipped the script on us. Negative 1 and a positive 17. Well, a negative times a positive is still a negative, and now the 17 is the bigger value, so that's going to stay positive 16x. Okay, now we're looking again. Look, negative 28, which means 1 plus and 1 minus. So what are some factors of 28 that could have a combined to be a 3 somehow? We know it's going to be 7 and 4. Which one gets the positive? Well, since it's positive 3, we need the bigger value to be the positive, x plus 7, x minus 4. And then we throw it all together. Negative 28. So we're going to have one positive, one negative. So one positive, one negative. Factors of 28 that could add to 12. Not 7 and 4. Not 28 and 1. Looks like 14 and 2. Those could combine to be 12. And since it's a negative 12, the 14 must take the negative. Because when we combine them, it's going to end up being negative. Look at us go. This is called factoring, folks. We are doing what's called factoring. Okay, so the big sticker, the kicker in the sticker is that when you are multiplying binomials, so in the binomials, when you are multiplying, when we have things in factored form, that was our whole goal, in factored form, we know that the constant times the constant, we've known that for a while, gives us a C term, and the pattern shows that the constant plus the constant gives us our B term. Okay, let's take that, put it right into practice here. Let's start on 7.6, 7.7. It's combined the homework, posted in Teams, and on OneNote. Next class is Monday. That's due for Monday. Way to rock it, people. Miss you guys. Bye.